Wonderful.
So you should have downloaded and or printed your chapter 4, the temperature conversion worksheet, and we're going to work through some of it together. Okay, so let's see. Okay, so we have some instructions up here. It says to plot the Celsius on the x-axis and Fahrenheit on the y-axis. So if you don't remember, this is the y, and then down here this is the x. So then we're going to go on, and so we need to do degrees Fahrenheit, and then we're going to write degrees Celsius. Let's make that look more like a degree symbol. So it's always important to label your axes so we know what you're plotting there. It tells you to plot the boiling and the melting point of water. So the boiling point of water is 100 degrees Celsius to 12 Fahrenheit, and the melting point or the freezing point is 0 degrees Celsius and 32 degrees Fahrenheit. So the reason why this is important is because I need to know how many dashes I need per unit. So I'm going to have 100 here, and then this is going to be 180. So you subtract the difference, and I need from 0 to 100, approximately 100 degrees Celsius, and then from 32 to 212, it's going to be 180 degrees Fahrenheit increase. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So the reason why I did this is because I'm going to try to maximize my entire graph. So if I take 100 and divide it by 31, that means each line is worth about 3, and that's kind of a lot. So I'm going to do every other is going to be, every line will be 5. So 5, 10, 15, 20, then we have 30, 40, 50, 60, 70, 80, 90, 100. So it doesn't use all of the graph, but it's really quite easy to see the differences. I'm using probably about 75% of my x-axes. So now I'm going to do the same thing for my Fahrenheit. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 39. Probably it's 40. So let's take 180 and divide it by 40, because I think I'm pretty close. So it says 4.5 approximately. So I'm going to do the same thing. I'm going to do by factors of 10. So the reason why we do this is we just want to use the majority of our graph, and that's, I think I might run out because yeah, I'm going to run out 30, 40, 50, 60, 70, 80, because I started at 32. Okay, so let's start at 20. And we're going to draw this little line right here. Means it's not, that we're not using all of them. 30, 40, 50, 60, 70, 80, 90. And the reason why this is important is because you always need to treat each graph as a new one. So it's not always going to be that you can just do by 5s or by 10s. Sometimes you might have to, still not quite, we're going to just make 210 up here because I don't want to make it any smaller. I could have done that by, started at 30. Anyways, okay, so now we plotted the points, and we did the axes. Now we're going to plot the actual points. So for the first one, my melting point is at 0 degrees Celsius and 32 degrees Fahrenheit. So I'm going to start off, and I'm at 0 degrees Celsius, and I'm going to go up, and I'm going to plot around 32. So between 30 and 40 on the y-axis, and this point is on 0 and on 32. Okay, so that's how that works. And this is the melting point. Now I'm going to do the same thing with my boiling point, except for it's going to be at 100 and then 212. So I'm going to go all the way over, and I'm at 100, which is right here. And I'm going to go all the way up to the very top. It's kind of hard, you lose your space. And I'm going to do up here. And I know it's a little bit over, but my line is probably not going to be exact. So it's all the way up at 100 and then at 210, and this is the boiling point. And now I'm going to connect the dots, and so this might be easier for you because you will be on paper maybe. Oh, I didn't do too bad. Okay, so I'm going to connect the dots, and this is going to be two things. One is it's going to be the relationship between Fahrenheit and Celsius, because anywhere along this line I could convert between Celsius and Fahrenheit. And it's also going to give us an equation, which is y equals mx plus b. So in order to solve for this, and we're going to do a lab on it, you have to know a few things. One is b is the y-intercept. It's where the line crosses x equals 0, which we just happen to know because that's this point right here. Because at 0 degrees Celsius, whatever the value of Fahrenheit is, that's going to be our b value. So we know that at 0 degrees Celsius, that is 32 degrees Fahrenheit. Now, y and x are going to be variables that represent Fahrenheit and Celsius. So we're going to leave them as variables. And then we'll change them into Fahrenheit and Celsius in a bit. Now, the one we need to know is m. And m is slope. And m, there's two ways. You could do it's rise over run, or it's the difference in the y values and divided by the difference in the x values. And the key here is we have to keep these two sets as pairs. So looking at this, the first pair is going to be 212 y2 minus y1. So this is going to be 212 minus 32. So you get the values from the y-axis. Now the x2 values and the x1 values are going to come off the x-axis. So that's 100 minus 0. And if you solve for that, you could get a fraction of 9/5 or a value of 1.8. So that's our value of m. So our equation is y equals 9/5 x plus 32, or y equals 1.8 x plus 32. And the key here is that y is Fahrenheit and x is Celsius. So we could say temperature in Fahrenheit is equal to 9/5 times the temperature in Celsius plus 32, or the temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. Okay, so these are the equations for converting between Fahrenheit and Celsius. Okay, so it says, first of all, estimate the value of Fahrenheit at 25 degrees Celsius using your graph above. So to do that, let's pick a different color. So we're going to estimate it at temperature of 25 degrees Celsius. That's roughly here. I'm going to go up, and I'm going to see where it hits the line, and then I'm going to follow that over to Fahrenheit, and I'm going to say that's approximately, let's say, 73 degrees Fahrenheit. It's an estimate, so we don't have to be worried about it being exactly right, because everybody's line might look a little bit different. You might have labeled your axes a little bit different, all of which is fine. Now, I'm a fan of the 1.8 times formula, simply because I tend to make mistakes with fractions, the 9/5, and so I usually use the 1.8, the decimal form. So now we're going to calculate what the temperature of Fahrenheit is at 25 degrees Celsius, and we're simply going to plug it in. So 1.8 times 25 plus 32. Now, the reason why I put parentheses around the 1.8 times 25 is if we remember, please excuse my dear Aunt Sally, we have parentheses, exponents, multiplication, division, addition, subtraction. So multiplication has to occur first. So I need to multiply these two before I add together. Okay? So I use the parentheses to remind myself. So I'm going to take 1.8 times 25, and I'm going to get a 45. And then I'm going to add to that 32. So the actual value is 77 degrees Fahrenheit. So my line is not all that great, even though I tried to make it look really good. So the estimated value, 73-ish, maybe yours is different, but the actual calculated value is 77 degrees Fahrenheit. Okay? Hardest part here is just making sure you multiply the temperature in Celsius by the 1.8 before you add the 32. Now the last part says to convert the temperature to Kelvin. So Fahrenheit to Celsius is not 1-to-1, meaning if I increase the temperature by 1 degree Celsius, it doesn't increase Fahrenheit by 1 degree Fahrenheit. It's an unequal incremental increase. But Celsius to Kelvin is proportional. So if I increase 1 degree Celsius, I'm going to increase 1 Kelvin. And so then I need to remember that the melting point for water was 273 Kelvin, and the boiling point was 373 Kelvin. So when the freezing point of water is 0 degrees Celsius, it's 273 Kelvin more. So the conversion is temperature in Kelvin is equal to the temperature in Celsius plus 273. So I'm going to take my value in Celsius, which was 25, and I'm going to add 273 to that, and that makes my temperature 298 Kelvin. And so remember the importance of writing our units. Remember, this is a number and a unit. The unit without the number is meaningless, and the number without the unit is also meaningless. And you can see here why. If someone said it's 25 today, you wouldn't know if that's Fahrenheit, Kelvin, Celsius. You might be able to guess, but it's important to include numbers. Okay, so this should really help you with the lab that we're doing, and then you have formulas you need to remember, so make sure you have your formulas down, and then when you're done, make sure you submit the assignment in the appropriate location where you found the assignment to download and or print.